Hello and welcome to QCT's presentation on how QCT Edge platforms accelerate the AI workload. Here is a picture of QCT's sales office in San Jose, California. For those of you who may not know who QCT is, or Quanta Cloud Technology, they are a global data center solution provider that combines the efficiency of hyperscale hardware with infrastructure software from a diversity of industries. We have a vast product line which includes servers, storage, and networking, and hyperconvergent software-defined data center solutions. Our parent company, Quanta, or Quanta Computer Incorporated, is one of the largest ODM and OEM server providers. They support QCT in designing, engineering, manufacturing, and system and rack integration, as well as supply chain support through the Quanta Global Network, all under one roof. QCT's global footprint spans across North America, and here, as you can see, here in San Jose, California, in Seattle, as well as a small facility in Nashville, Tennessee, and then also across Europe and as well as Asia. QCT powers most of the global Tier 1 hyperscale data centers, telcos, and large enterprise. QCT's customers extend from hyperscale to enterprise and telco. QCT offers a complete product line all under one roof to fulfill all your needs, and we call it 3S1R, the 3 S's being server, storage, and network switching, and then 1R for racks. QCT offers a diversity of products to provide you for your end-to-end workloads for 5G and AI. If you look at this table here, starting from the right side for the data center, you can see we offer a couple products for training in AI and for end-to-end workloads of video applications. And as we move towards the left, for regional data centers, we offer CPE, BNG, EPYC, NFE, and CDN products. Then also looking at the indoor edge for RAN and MEC, we also offer a couple products. And then for outdoor edge, we offer the S1K. QCT offers several GPU-specific servers, which are depicted here. So if you look at the arrow on the far right showing complexity going from low to high, and then we also have the little colored blocks that show specific applications, and then the column for the number of GPUs. So we start from the bottom looking at our D43KQ and D53KQ servers. These are AMD-based platforms, and they each hold 2 GPUs, and they are good for HPC, inference, and VDI. Then our second one, moving up, our D52BV 2U system, Intel-based, holds up to 4 GPUs and is ideal for HPC, training, VDI, rendering, and inference. Then next up, our D52G-4U, which will hold up to 8 PCIe-based double-wide GPUs. And this is good for specifically for HPC and rendering. And then lastly at the very top, our D52G4U GPU box, which holds up to 8 SXM2 or NVLink GPUs. And this is well tuned for training. Over the past couple years, we've seen extreme adoption of NVIDIA's T4. It's a very versatile, smaller, more compact sized GPU and ideal for inference training. So here we're showing the full QCT product line. And each of these systems in their own special way offer both a different CPU platform, but also offer either scale up or scale out design or both. And they also offer various CPU to GPU ratios. So if we look from the bottom up, we can see models that offer either 2 GPU support, and again, a selection of Intel-based or AMD-based CPUs. And then multi-node models that offer up to 2 GPUs, 2 T4 GPUs per node, either in an Intel or AMD-based platform. And as we move up the table, you can see the number of GPUs offered increase. Here we have QCT's product lineup of the AMD CPU product line. And if we work from the top down, we have our 1U general purpose server the D43K-1U. This offers dual AMD processors, up to 32 DIMM slots, and up to 12 NVMe SSDs, as well as our new introduction of the OCP 3.0 PCIe networking card slot, and up to 5 PCIe Gen 4 expansion slots. And more specific to GPUs, it will hold up to 3 NVIDIA T4s. Next up is our 2U general purpose, the D43KQ. This is also a dual AMD CPU platform, holding up to 32 DIMMs, up to 12 3.5-inch hard drives, or 24 U.2 2.5-inch drives. Also, again, the OCP 3.0 PCIe networking slot, up to 10 PCIe 4.0 expansion slots, and up to 2 double-width NVIDIA V100 GPUs, or up to 5 NVIDIA T4 GPUs. And lastly, our S43KL1U, which is our single AMD CPU platform, offering or supporting up to 16 DIMM slots, up to 12 NVMe SSDs, the same OCP 3.0 networking slot, and up to 5 PCIe Gen 4 expansion slots, and up to 2 NVIDIA T4 GPUs. Continuing with the QCT AMD platforms, we have here our density optimized 2U 4-node server, the S43CA. This is a 4-node in 2U packaging, each node having a single AMD CPU, up to 16 DIMM slots, an aggregated networking capability of either single or dual 25 gig ports per node, and up to 1 NVIDIA T4 GPU per node. And lastly, our all NVMe storage server, the D42A, is a 2U single AMD CPU platform with up to 16 DIMM slots, 24 NVMe drives, and up to 2 100 gig networking slots. There's been a lot of talk about edge computing and how the importance of moving compute power, storage, and also GPU or AI and inference out to the edge. And this little drawing of a typical city shows a lot of the applications for edge computing, whether it be smart transportation, smart healthcare, mobility and Wi-Fi, a connected building, connected cars, smart homes, etc. Edge computing works by moving as much compute or processing power and GPU power out to the edge. So it gives the ability of the applications to run and also get results, do analysis, and provide the data or results right there at the edge, whether it be on a mobile device such as a phone, a tablet, or in manufacturing for the robotic arms, or for cars. The car itself can analyze data and react on it, or use the results of that data. So we'll see over time more and more systems will need to, whether it be packaging to be able to fit into these smaller areas, or to be able to work in harsher environments such as manufacturing floors, or vibration and in a car, etc. And looking at some typical application use cases for edge computing, we can see here what many know of VR gaming or gaming capabilities. We're all familiar with autonomous vehicles or semi-autonomous vehicles. So being able to move more compute power to the edge into a car. And this could be our personal cars or semi-trucks for delivery or for public transportation. And then we can look at government agencies or banks, and then also for manufacturing machinery, moving to the edge for being able to build systems and be able to manage the raw materials to build it, and knowing when it's out of supplies, or knowing if a design changes, you can push that design out to the floor and the robots can now adjust and change their manufacturing process. Medical image analysis, we're familiar with X-ray analysis or cancer analysis or whatever it may be, that we can gather the data at the edge, analyze it, get the results, and act on those results immediately rather than having to send it back to the core data center and wait until that data gets churned. Now let's take a look at QCT's telco product portfolio. You may be wondering, well, why are we talking about telco products here for GTC 2020? But with NVIDIA's announcement of their Aero SDK and with the fast emergence of 5G networks, there is a blending or melding of the technologies, right? So 5G is in essence telco, but NVIDIA has embraced it again with the Aero SDK and the fact that you can now put NVIDIA GPUs out at the edge, whether it be a 5G network or a traditional edge computing network. And in this table here, or this chart here, we show going from right to left, the data center, central office, and indoor edge, and a variety of products that QCT offers, as well as outdoor edge and customer, or CPE product. So the next several slides, I'll go into more detail covering these data center, central office, and indoor edge platforms. Here we have the ST2H-1U. It offers an ultimate I/O flexibility for an edge server. It's a shorter 400mm chassis and offers front I/O module design that's flexible and that you can change up whether you need more network connectivity or more storage. You can have up to 2 PCIe expansion slots and use these for FPGAs, GPUs, or LAN connections. You can have up to 2 U.2 SSDs for cache acceleration. We do support negative 48-volt DC power supplies, and it has support for both front and rear power inlets, as you can see in the pictures. So the power supplies are in the front, as well as all the drives and network connectivities. But you can also run dongles that will go carrying the power back out to the back so you can connect to PDUs that are in the back of the rack. Here you can see the chassis dimensions, and again looking at the front view, but it's a 400mm deep chassis, or about a little over 15 inches, almost 16 inches deep. So offers that flexibility to get into smaller data centers or relay racks, or again for telco data centers. The SD2H is offered in 2 SKUs, the top SKU being the networking or inference. So this gives you predominantly PCIe slots, 3 of them, where you can put GPUs as well as network interface cards. And you can see the callouts for some of the other connections, micro USB, the management port, 2 USB ports, power button, the power supplies in the front. Our second SKU is the cache accelerator SKU. And this, in place of the PCIe slots, gives you 2 U.2 SSDs and another PCIe riser slot, which you could put either a GPU or a network card in. Looking at the rear of the chassis, you can see since it's a front I/O access only, the only items in the back are the 6 single rotor hot swappable fans and the 2 rear AC sockets, which are connected to the power supplies in the front. So as I mentioned earlier, if your PDUs in the rack are in the back, you can still connect them to the back by using these AC sockets. And then lastly, there's a center module for an antenna of adding the Wi-Fi or LTE module. The ST2H-1U offers a flexible module assembly. So as this depicts here, either the PCIe module slot allows you to put in GPUs dual width, such as the NVIDIA Tesla T4, or you can put in the module for the drives, the 2 U.2 drives that are shown in the lower picture. Here we have a little more detailed specifications on the SD2H-1U for the networking or inference SKU. In the blue box you can see the dimensions, the CPU callout, the Intel Skylake D processor supporting up to 110 watt TDP, the 8 DIMM slots, the 2 PCIe by 4 slots for 2280 M.2 storage sticks, and the 2 expansion slots, both PCIe by 16, one being a full height half length and one supporting full height 3/4 length. And then the pictures depicting the front view, calling out the 2 risers, and then also the rear view. And here are the detailed specs for the SD2H-1U cache accelerator SKU. Here, same dimensions, the same CPU, the single Intel Skylake D processor, the 8 DIMM slots, and then for storage now we have 2 15mm U.2 as well as 2 PCIe by 4 2280 M.2 stick slots. And then for expansion on the riser 1, a single PCIe by 16 slot, full height, half length. The next system we'll look at is a NUMA-Balanced D52Y-2U. the 2U 400mm deep chassis offering twice the number of expansion slots as the 1U system we just talked about. Same front I/O axis, so all interfaces are in the front, swappable drives are in the front, as well as the power supplies. This system offers up to 10 NVMe small form factors for local storage, supports a negative 48 volt DC power supply, and offers also the same front and rear power inlet. So even though the power supplies are in the front, if you need to have connectivity to your PDUs in the rack that are in the back, this can accommodate it. This slide shows the D52Y-2U GPU SKU and emphasizing the 400mm shorter chassis depth, and also showing the GPU placements as you can see them in the top. And here we have the D52Y-2U NVMe SKU. So again, same physical dimensions with the 400mm depth, but showing you the NVMe drive trays. Here we have a close-up front view of the D52Y-2U, showing you the various PCIe slots, and with the callouts showing where you can have a single dual GPU, a half-height, half-length slot, 2 of them in the middle, and then another dual GPU on the right side. You have a full-height, half-length slot on the lower part of the left corner, and then the 2 SATA or NVMe drives, and then the 2 power supply units. Here we have a close-up front view of the D52Y-2U NVMe SKU. And as you can see here, the 8 SATA or NVMe drives with the hot swappable bays, the full height half-length slots along the bottom, and then the 2 power supply units in the front. Here's the rear view of the D52Y-2U. And similar to the 1U system, you can see there's only the rear AC sockets, and then the 5 single rotor hot swappable fans. Next up, we have our D52BE-2U offering computing in the edge. This is our top shelf CMP processor platform, slightly deeper chassis at 579mm, offers up to 7 PCIe expansion slots and up to 3 terabytes of memory capacity. If you look at the front view of this chassis, the top left picture, you notice what's missing is any hot swappable drive bays. So this system doesn't have any drives in the front. It's again more for computing or processing power at the edge, and we offer 2 drives depicted there in the rear view. Here's a look at the chassis with its dimensional characteristics. So again, the 579mm or 23.6-inch depth, and then again the front view showing no drives at all. In the next few slides, I want to highlight some of the live demonstrations we ran at previous shows such as SC18 or Supercompute 18, OCP Summit 2019, and GTC2020 in the US. So these 2 graphics show 2 of the systems that we used at these demos. On the left being our X11C-8N, which is an 8-node server system for multi-object detection. And on the right, our D52BV-2U GPU server for multi-object detection. So next couple slides will go into detail of what the setup was and what we were demonstrating. So on the D52BV with the P100 GPUs and OpenPose, we showcased a real-time multi-person keypoint detection. So in the graphics, you can see that as a person walked up in front of the demonstration, we were able to pick out each of the people and do an outline, multicolored outline of their arms, hands, and as well as picking out their eyes, nose, and mouth. And it would track them through their motion, so as you moved around in front of the cameras, it would still track and move with you as you moved your hands or your arms. For our other demonstration, we used our X11C-8N, which is an 8-node 2U server, and each of the nodes had NVIDIA T4 GPUs, and we were showcasing multi-object detection. So what we did was able to do a scale out across the nodes, as you see in each of these images, the number of pictures on it, as well as the little colored linear bars along the top. So we showed as we brought out each node. So the first one, the top left, shows one node and we had a total of over 3,500 images. And then we scaled out to 3 nodes and now had over 10,000 images. Then we scaled out across 5 nodes and had over 17,000 images. And then out to 7 nodes, we had over 23,000, almost 24,000 images being processed. Here's a little more detail of our setup for that X11C-8N, an 8-node server, each with E3 CPUs and Tesla T4 GPUs. Based on intelligent video analytics reference design, we decoded 38 streams concurrently on a single node, and we accelerated deep learning inferences on NVIDIA DeepStream SDK 4.0. And you see in the diagram the GPUs across the 8 nodes, and then the 1 node over 7 nodes, and then the 1 node used as a video streaming server. And the box shows you some of the specifics such as operating system, device driver, and CUDA toolkit. And here's another diagram showing the RTSP streams coming in for hardware decoding, and then going through CUDA and going into the CUDA tensor, whether through the NVStreamMux, the NVInfer, NVTracker, and then also spreading out into the inference for the car makers. And what this was for a streaming that showed various cars and depicting what the car make and model was. And here are some more details on that same demonstration on a model for bounding box detector. So we ran ResNet 10 and pre-trained model to generate a detected bounding box of 4 classes: vehicle, road sign, a two-wheeler, or a person. We ran it through a stream multiplexer into NVInfer, and then we were able to come out with those characteristics of our bounding box detector so we could detect whether it was a vehicle, a road sign, a two-wheeled vehicle, or a person. And this slide shows details on our KLT tracker or NV tracker algorithm implementation and how we utilize that for our demo. And for our classifier for the car models, again in our video demonstration that showed various images of cars, and as the box detected, it was able to define what type of car it was, whether it was a sedan, SUV, or a truck. So we ran the classifier of ResNet 18 network that trained on the ImageNet. And through the tracker, we ran the NVInfer for car model, and again, it classified them as a van, sedan, SUV, or a truck, for example. Now, following up to the type of car, we also did a classifier for the car make. So again, ran it through ResNet 18 network, it trained on ImageNet, and as a secondary identifier through NVInfer, it defined whether it was, for example, a BMW, Mercedes-Benz, an Audi, or a Toyota, or any other numerous car makes. Here we show our software stack that we ran on top of our server, the X11C-8N. So the GPUs used were NVIDIA Tesla T4s, shows the host OS, and then within that green dotted box, the NVIDIA GPU containers comprised of the CUDA driver, the Docker engine, the container OS user space, and Tensort, the CUDA toolkit, video codec SDK, and the DeepStream SDK. Then at the very top of the stack, the intelligent video analytics application being the DeepStream applications. And this is the actual monitor that we had running, showing you all the various images of cars, and we're showcase here with the identifiers of the red boxes classifying each of the vehicles as the stream came through. And then we go back to the main screen, it shows a mixture of various images. Then again, going into one of them, going through a toll booth, and it shows it classifying each of the vehicles and as well as the person. So as we cycle through, again, back to the main image, you see all the various images, and here's one showing 2 people and drawing the identifier box around them. And then continuing through various screenshots, you can see in the real time it's classifying and grabbing, and we go back to the main screen. Then here going down the street, picking out a car, and giving an identifier number, a person on the sidewalk. And that's the demo as it continued going through, and you can see each of the smaller images, and whichever one that you either clicked on or into, you can get a closer look of what the classifiers were doing. Looking for innovative cloud, telco, or edge solutions? Come to QCT, who else? For more information or details, please go to www.qct.io. And thank you for your time today and watching this presentation.